Um, this is called the nth term test for divergence. Okay, and this is what you're going to be kind of tested on a little bit on the AP classroom. Now, this test is only for divergence. Ben, does this theorem state anything about convergence?
No, just divergence.
Just divergence. So we cannot use this to conclude convergence ever. Okay, so if we get a 0 as my limit, okay, this says the limit fails to exist or it's different from 0. If it's either one of these things, then we can say definitely that the series diverges. Okay, so we have that first problem here. And what we're going to be doing here is we're thinking this as a limit. And Nithin, I want you to tell me what you get for the limit of this problem as n goes to infinity.
Goes to infinity. Would that be 0?
No, it's not going to be 0 because the powers are the same. There's a cubic on the top and a cubic on the bottom. So negative what?
Negative 1/2.
Yeah, negative 1/2 is my limit. Can we use this particular nth term test for divergence on this problem, Nikki?
No. Oh, yeah.
Yeah, we can, right? It says if the limit is something different than 0, then the series definitely what?
Diverges.
Diverges. Okay, so this particular series right here, right, diverges because of that. So it's a really simple test. Okay, but the test is not always conclusive. Okay, now the next one, Ethan, we have this limit of 3 times n times e to the n over n squared plus 1. What happens when you put infinity in the numerator and denominator?
You get infinity over infinity.
Right, so what's that indication to us to try to figure out to do? What are we going to do next, you think?
L'Hopital?
Yeah, L'Hopital. Yeah, now, without doing it all the way through, Ethan, what is the denominator going to eventually get to if we take multiple derivatives?
2.
Exactly. And don't you agree that the numerator is always going to have an e to the n in it?
Yeah.
And it's going to be a product rule, but we're not going to do it. We just know that there's going to be a product rule probably multiple times, and we're going to have something that has some n's in it going to infinity. So without going through the whole problem, we have infinity over 2, which is going to be eventually what?
Infinity.
Infinity. Very good. So Ben, can we use this nth term test in this problem?
Yes.
Yes. And infinity does mean it does not exist. So my limit doesn't exist. Therefore, this series diverges. As long as we don't get what?
0.
As long as we don't get 0. Okay, then we're going to be okay. If we get 0, okay, then we're not going to be happy. Okay, because that's going to be inconclusive. Okay, this last one. Nithin, what's the first term of this series?
Negative 1.
Yep. And then Nikki, what's the next term?
1.
Okay, and then Ben, next term.
Negative 1.
And then Ethan,
1.
plus 1. Okay, does this appear to be approaching a number? Does this
0.
appear to be, no, we're not talking about the sum of the terms at all. We're talking about does it, if we looked at this going on forever and ever and ever,
No.
would we ever approach a single value?
No.
No. That's what a limit is, right? A limit is when you approach a single value. So this is not happening, isn't it? It's basically always going to alternate between +1 and -1. So this limit as n goes to infinity, d and e does not exist. So Nikki, can you use this test?
Yeah.
Say that again?
Yeah.
Yes, because we can use this test if it's different than 0 or doesn't exist. Okay, it's that simple. So all three of these diverge. Okay. Now, next page. Look right here. When you what? When you cannot use this test. What was the only time that we said you cannot use this test?
If it equals 0.
Right. If my limit is 0, right? So we have this little pi over n in the first problem. As my n approaches infinity, Nathan, what's pi over infinity?
0.
So as my n approaches infinity, my pi over n, right? My pi over n approaches 0, doesn't it? Okay. So let's think of this then as sine of 0 in a way. And what is sine of 0? Nathan?
Oh, sine of 0 is 0.
Yeah, that one we should know. We should know our trig stuff, right? So can we use the test?
No.
No. Okay. The test does not say if it goes to 0, then it converges. It does not say that. Okay. So anytime you get a 0 as a limit, then your test is inconclusive. Okay. Inconclusive.
So if it's not converging, what else can it? Well, if it's not diverging, what else can it do then?
Well, this test does not say that if it becomes a 0, then we know sure it converges. It still can diverge.
Oh, okay.
So basically, going to a 0, right? Having a limit of 0 is a necessary condition. It has to go to 0 to converge, but if it does go to 0, that's not good enough. We still don't know, and that's why we can't use the test. This test is only for testing for what? Divergence. Okay. Now, Nikki, 1 over n squared. What does 1 over n squared do as n goes to infinity?
0.
0. It approaches 0, doesn't it?
Yeah.
Okay, so these terms here are getting what? Smaller and smaller and smaller, aren't they?
Yeah.
They're approaching 0. And Ben, what does this little -1 to the n do?
It alternates between 1 and -1.
Right, so my terms, though, are not just bouncing back between -1 and +1 but the signs are, aren't they?
Yes.
So my terms here would go from like my first term, you would have a -1, right? And then my second term would be adding a quarter. And then my third term would be then subtracting a ninth. So these are approaching what?
0.
0, right? But they're just both, they're positive and negative fluctuating because of that -1 to the end, but they approach 0. So my limit of my nth term is not different than 0, is it? So again, this test cannot be used. So that's why we have this title here. When you cannot use this test is when you have a limit of 0. Inconclusive. Okay. Ethan, 1 over n. See this piece right here?
Yes.
What does 1 over n do as we go to infinity?
Goes to 0.
That goes to 0, doesn't it? Therefore, we have natural log Nathan of 1 plus something that's approaching what? 0, aren't we? So if that piece is approaching 0, then the whole function's approaching natural log of 1. Nathan, what's the natural log of 1?
0.
0. Good. So natural log of 1 is 0, so can we use the test? Cannot use the test. So in all three cases on this page, all my limits went to 0. This test is inconclusive. Okay. All the problems on the previous page, they all either did not exist or they were different than 0.
Mhm.
Therefore, we know for sure they diverge. You guys have any questions over these?
No.
Okay. So I'm going to stop the sharing part. go back to what we were doing. All right. So it's a short lesson, but that's how it's going to be. We're not going to do like a full 30-minute lecture or class thing. We're going to do small little problems like that, enough to let you guys practice a few on AP Classroom. Okay. So I'm going to be posting this video along with the problems here this afternoon. Okay. You guys, thanks for stopping in, and we'll hopefully see you soon.
Can I give my table mates a shout out?
Can you what?
My table mates, my partners.
Oh, there's Nikki. She got off the screen. Ah, there's Nikki.
Not mean to do that. Okay.
We're still recording it though. All right.
Nice. Okay.
All right. Yeah, Nate, you gotta get your table people to show up to the meetings. So,
I'll try.
yep. Sounds good, man. We'll talk to you later. Have a good day.